Hi, welcome to the Calculus 3 and assignment practice series. And this video, we're going to in the unit number 2, partial derivatives. And for this video, we're going to work on some problems on the assignment number 2 worksheet, limits and continuities here. Okay, so now let me go to the worksheets here. So here is the worksheet. And the first problem I like to do, it will be the problem number 9 here. So we want to find the limit xy approach to 0, 0, and this is x fourth minus 4y, x squared plus 2y squared. So now if you plug in the 0, x equal to 0, y equal to 0, what you're going to have? You're going to have a 0 over 0. So when the 0 over 0, this is undetermined form. So the one way we can do it is like, remember I mentioned in the lecture series, we said somehow if we can, prove it, limit is not exist, maybe it's easier. So let's, let's take a look see here. So we said find, let's try to approach to the 0, 0, right? So from the x-axis. Remember, right, we have many directions. So the path you can approach to the 0, 0 from x-axis. So from the x-axis here, that means y equal to 0, right? So that means y equal to 0. That means the x-axis. Okay, so now let's take a look at these ones here. What do we have? So it's xy approach to the 0, 0, and y equal to 0. So we have x fourth, and what here? The bottom here, this is x squared. And then this will be equal to limit xy approach to 0, 0. Or you can put this is y equal to 0. So this is x to the what? So this will be x to the squares, right? Okay. So this will be the x to the square. So it will be equal to 0 here. How about now I approach to the 0, 0 from y-axis. So from y-axis, that means x equal to 0, right? Okay, so now this one's here, I mean, approach to xy, approach to 0, 0, and from the y-axis is here. So that means in here, x equal to 0. So I have a negative 4y squared, and the bottom here is 2y squared. Then I cancel this one's here. This is a bad, I think this is a bad notation here. I should have, so it doesn't have the equal signs here, right? So that means it's limit approach to 0. So this will be limit xy approach to 0, 0. You cancel that. What is here is negative 2. So if negative 2, so if you approach to limit with the constant, so this is negative 2. This is, I'm sorry, this is not the x equal to 0. Okay. So this is I want to say is here. Okay, so one limit, one path, your limit approach to 0, one path, the limit to equal to negative 2. As long as we find one path is not equal, then we will say what happens here, the limit not exist. Okay, all right, so now let's take a look at number 13. For the number 13, so here we said xy equal to 0, approach to 0, 0, you put it over here. This one is also is 0, 0. So in here, if you try the several paths, and in here I'm not going to try like this. So like if you don't believe me, you can try from the x-axis, y equal to y-axis, x equal to y. So when you try several passes, and they all approach to the same value. And we say that now you cannot say the limit exists because we have an infinity number of the passes here. So the way, after you try 2 or 3, they all approach to the same one, then we might probably need to take the different approaches here. So the different approaches here, this is what we're going to use. We call it a squeeze. Okay, so we're going to use, we call it the squeeze theorems here. Or some people say sandwich. That means if the both end, if you squeeze it, right? If the both end, they approach to some number, then this one has to be approach to that number. So take a look here, right? So these ones here, you take a look at this y, and this is x squared plus y squared. So I know the absolute value of the y is less than equal to x squared plus y squared, right? Because x squared plus y squared, x squared is always something positive. So x squared plus y squared is always will be something greater than 0. Okay, so now you divide both sides by the x squared plus y squared square roots. So you will have y, absolute value of y over x squared plus y squared is what? Less than equal to 1 here, right? Okay, so now I'm going to do something here. So this is the xy, so I put the xy, and this is x squared plus y squared, right? So now for this ones here, I say, okay, I times absolute value of the y on both sides. Okay, so this is x squared plus y squared. So this is less than absolute value of the x, right? Because absolute value of x is a positive, right? And so when you times it, both sides will not change the value. And also in here, I know my left-hand side here, this one has to be greater than equal to 0 because they're all positive, right? So this one going to equal to 0. So now in here, I will say, okay, so now if I have the, okay, so here, this is a limit, right? X, Y approach to 0, 0, right? And then I know this one's here, the absolute values here. So what is this one approach to here? Okay, so this one's here. That means like in here, you take a limit on the all 3 side. So this will be equal to limit xy approach to 0, 0 to the 0 less than limit xy to the 0, 0. And this is x and this is y and this is x squared plus y squared is less than equal to limit x approach to 0, the absolute value of x, right? So I just, I just take the limit to both sides. So in here, this one's here, this is a constant, right? So this side is 0. And this one's here is limit x approach to 0, the absolute value 0 is here, right? So I know this functions here, right? So this function is limit xy approach to 0, 0. This functions here. So they kind of squeezed by both ends. So both ends will approach to 0. So I know this function going to approach to 0. That means the limit x and y, if you take the derivative, if you take the absolute value of this function will approach to 0, that means this function xy is here. This is x squared plus y squared. What is this limit going to approach to? Approach to 0. Right, so by the squeeze theorem, so this limit exists, okay? So be very careful. So, when you do the squeeze theory, that's what you kind of to see, how do you find the both ends here, okay? So in here, give you a hint here, so for the number 16 here, right? So for the number 16, you can do the same things here. So you say here, y force and the x squared force plus y force, right? So if you take a look at this part, so this part is less than equal to 1, right? So you start out with here, this is y force, and this is x force plus y force. So this is y force. This one is less than or equal to 1, right? And this one is greater than or equal to 0 also because it's all even power. And then you can times the absolute value of x, and then you will get it, right? So that is a pretty, pretty straightforward. So make sure, if you tried a couple passes and they all cannot give you the conclusion, then you might want to try the squeeze theorem to see you can prove the limit exists here, okay? Okay, so now in here we said, okay, so I'm going to do number 25 here. So in here they say, hey, h of x is a composition of the function g and f. So I want to find the set of the point, h is continuous. Okay, so the first thing here is, okay, the h, right? So h of xy is equal to g composed of the f, right? That means g composed of the f. That means you put the f back to whatever the g. So what do you have here? You have 2x plus 3y minus 6 to the square plus square roots of the 2x plus 3y minus 6. All right, so if you take a look, so this is the function of the what? The hxy's here. So where is the continuous? So we know this term is kind of like a similar like the polynomial term. So this one limit exists and the limit are going to equal to the function value. And so the here, that's the only ones here is this one. This is the inside, the inside the square roots. So just like we say, if it's inside the square roots, so what do we need to do? We need to make sure it's a non-negatives, right? So that's why we say it's 2x plus 3y is going to be greater than equal to 0. So that's what, 2x plus 3y minus 6. Okay. Okay, so 2x plus 3y minus 6. Minus 6 greater than equal to 0. That means 2x plus 3y greater than 6. So if you change it to the slope intercept form, you will say y is greater than equal to what? Negative 2/3 of the x plus 2, right? So that's why I know, because this is the domain, so I know this function going to be continuous at the domains here on all the xy, given that y has to be greater than equal to negative 2/3 x plus 2. All right, okay, so now I will do one more. So this one's here is 37, okay? So this 37 is here. So let's take a look. How do we do this one here? So let me give a little bit more space here. Okay, so here, okay. Okay, so here, all right. So now the number 27 is here. So we said, okay, so for these ones here, first let's know how to read it. So the function value does exist, right? So when the xy equal to 0, 0. So we know from the continuous, what do we know? That means the function value has to be equal to the limits, right? So for all these xy not equal to 0, this one is no problems here. So when the xy, so the first thing now we need to say, hey, what is the xy? When they approach to 0, 0, the f of xy will be. So from here, you will see here, you say, hey, if you put a 0, 0, what do you have here is 0 over 0. It's not determined. If it's not determined, then I don't know what is the limit. You can try to the several different paths to see, you'll be able to find the different one. So for this one, if you try the different paths and you find out that you cannot make conclusions, right? So we might need to think about use the squeeze series here. Okay, so for the squeeze series here, right? So I'm looking for here, right? So if you take a look at x squared, this is 2x squared plus y squared. What happens here? This one has to be less than or equal to 1, right? Because y squared is greater than 0, and this one is bigger than here. So this has to be greater than or equal to 1 here. And also this has to be greater than 0 here. correct? Okay, and then now I still have this number, right? I still have this y cube, you know, in my equation. So I will say, okay, let's try to take a look. So if this is the x squared, and now I have y cube, I put in the absolute value. Then here, this is the, so here, this is the 2x squared plus y squared. Okay, so you times the absolute value of the y cube. So that means I have the y cubes here, right? You time absolute value is zeros here. Now let's try. Okay, so say the limit xy approach to 0, 0 of these numbers here, x2, y3, and the 2x squared plus y squared. This will be greater than 0, and then this one is the limit xy approach to 0, 0. What do I have here? Y cube. So what is the y cube when y equal to 0? This one approach to 0. So see here, this limit was squeezed by the both end. So what do we say here? So we say the limit xy approach to 0, 0, then the x squared y cube, and this is 2x squared plus y squared. This is going to approach to 0. So we say this is the limit when x approach to 0, but the function value is 1, because this is not equal to f of the 0. This is 1. So we know if a function is continuous, the limits has to be equal to 1. So what do we say? You know, the function f of xy is continuous at every point except what? Except at the 0, 0. Even like in here, they give you the function value, but your function value does not equal to the limit you approach to. Okay, so basically what is this assignment here? This assignment is want you to find the limits and determine the continuity. So remember, you know, find the limits. First one, you probably want to find the limit not exist. If you can quickly take a few passes here, like x-axis, y-axis, y equal to x, those typical passes here, to see will they give the different limits value. If they do give a different limits values, then you will say, hey, the limit is not exist. But if they all give the same limit values, that doesn't mean the limit exists, because we know there are infinity numbers of the paths to do the limits, right? So then the next step, the strategy is you might want to use a squeeze theory. Sometimes we call it a sandwich theory. That means you want to find the functions between the two functions, and then you can like squeeze that and kind of bounded it, right? So like in here, this one's here bounded by 0 and 0, so this one has no choice. It has to approach to 0, right? Okay, that's it. That is this worksheet, and most of the problems here are pretty straightforward. Okay, so be careful about number 37, about the continuity. Then like the other problem I did here is like number 13 is how to use the squeeze theories here. All right, that's it. And you guys have a good day. And so this first two assignments are pretty simple assignments. You just need to be careful about a few things here, right? Okay, that's it. I hope this help you to do this assignment. And okay, have a nice day, and I will talk to you in our next video. Okay, bye-bye.